Hello, my name is Steve Samuel from Design Visionaries, and this is part two of videos that we are using to show the envelope command, being able to calculate the clearance of some robotic arm or some mechanism to make sure that you're safe, to show how you can avoid crashes, which can be extremely expensive. They could actually kill people. So what we have here is a simple actuated arm, and as you can see, I have an animation of that arm. I've got drive motors on it, and the drive motors are motors for the piston and motors for this rotational piece here. So that's the full range of the animation that I have. As you can see, there's these two drive motors. There's a position motor. So this is the one on the slider, the piston, if you will. It goes 10 inches, then minus 10, 10, minus 10, 10. That's that. And then this position motor is just a 360-degree rotation about the center. Great. So I want to know where the end of this piece of geometry will end up. And so what I can do is go to the envelope command, envelope. I can select the rigid bodies that I am interested in seeing where they go. And I can find an accuracy, I can find a translucency or set a translucency and simply say, okay. And then there's a lot of calculation that's going on, and so it takes a while. But here it is with two solids that really show the exact path of where the entities end up as they swing along or as they go through the whole animation. So as you can see, there's the end of that bar going up and down as it goes round and round. So that's incredibly useful because if you're designing something that's very intricate or something that's tightly spaced, you'll want to know what, if anything, it's going to crash into. Okay, so that animation is that envelope requires the animation to be done first. But there's another kind of envelope that I want to show you. So I'm going to hide these. And that is the iterative envelope. The iterative envelope is more powerful in a way because it allows you to calculate all the possible perturbations, if you will, all the possible locations of all the entities. And so if you have the whole mechanism created and you have the different joints, you can tell them an extent or what their possible plus or envelope, I should say, is, and then it will move the parts and it will make another envelope for you. But in this case, it's going to be a bigger envelope because it's trying to take into account the full motion of all these parts. So for example, this swing base, that's this little part right here, it goes around and around. It has, let's say it has a 180-degree rotation angle. So we're doing that. So in this little analysis, it's going to go from 0 to 180. And then there's a revolute here, let's call it the swinger boom revolute, this one right here. So we're going to put in, let's say, 45 degrees here. And we're going to just do a pretest to see that that's going to go 45 degrees like that. So great. Now, here's the problem. When I select the rigid body, I'm going to get an error message because it says the kinematics chain is not complete or involves joint that is not supported. So from experience, I know that this slider is not supported. So what I'm going to do for this analysis is I'm going to do a new solution. I'm going to click on New Solution, and instead of going with Solution 1, I now have Solution 2. In Solution 2, I've got to do a bit of work. I've got to do a rigid body here. I'm going to call it 1. A rigid body here. I'm going to call it 2. A rigid body here. I'm going to call it 3. And a rigid body here. I'm going to call it 4. Okay, then I'm going to put in some new joints. These are joints that are only specific to this solution. So there's a joint between there and there, which is going to be a revolute joint. I need a vector. vector here. I need a center point to apply that vector to. And so there is a revolute. I need another revolute from this one to that one. And put that right there. Apply. I've got a rotating joint this way and a rotating joint this way. I might want to go into that revolute and make sure that I have the right hand rule. Let's just do a little thing here. Let's go into the iterative envelope and select that revolute, that second revolute. Say, oops, that's this one. Let's call it 45 degrees and see what it does. Okay, so what we know is what has to happen is that revolute has to be switched. So let's go into that revolute, switch it around. That, okay, had it right the first time. I need another joint, which is a fixed joint. That. Okay, and now I can do the iterative envelope. When I click on iterative envelope, it allows me to figure out how much range of motion I want on these joints. So for this one, I want the 45 degrees. For this one, I want, let's say, 300 degrees. Okay, so I can test this, pulling that over like that. I don't care about these members for this analysis. It goes up like that. I don't care about this member for this analysis. And good. And so finally, I set the translucency level, set the accuracy, which in this case I'll use medium. Okay, all of that's all together. And now I will select the entities that I want to keep track of. This one and this one want the motion envelope for that. And basically it's iterating on all of the joints. And when I say okay, or when I say apply, it's going to think for a second. It's going to do that first, and then it's going to take that and swing it around the next joint. That's why it's so big. You can see that there's whatever I'd said, 300 degrees of it. And then the iterative envelope resets. So it just does this solid, faceted solid, and then it resets. So there you have it, the iterative envelope. You might want to use it because you have, let's say, an animation, a path that this thing is going to go to, but you want to make sure that in the future, if the path changes, that nothing will collide with it. So there you have it. It's a solid. If I go to the part navigator, you'll see that there's a way here that I can show these non-timestamp geometry. I can hide and show them there, so I can hide that one. And this one I can hide as well. Okay. And then, I can start looking at the ones that I've done previously. There's a scribed one. Okay. So that is extremely powerful. Now you know what's the safety zone of this whole thing. So where do you stand so that it can't hit you? Again, this technique can be used to avoid crashes that could potentially cost you life, a human life, or millions of dollars, or both. So use it in your good health. Again, my name is Steve Samuel from Design Visionaries. Thanks for your usership. Please like and subscribe this video, and others, please share these wonderful techniques with at least 1,000 of your closest friends. Thank you. Take care.